Okay, welcome to CSE1PE. We're just having a quick discussion about what the market was like for programmers. Okay, so there's 23 people currently in this room. As I said a little bit earlier to everyone, I'm expecting next week that everybody will be on camera if they're attending. Otherwise, they won't be attending. But in any event, welcome. And for those of you who are watching the recording of this, I also do need to point out that there'll be some things happening in class that won't be recorded, as you know, we'll be turning off the recording sometimes when I'm working with students. But we were talking about how many jobs there were. So, bits of information that I'm privy to that you guys don't know. Anyone want to have a guess how many students are enrolled in this class? 50, 100? They're good numbers. There's actually 200, okay, just in this online class, okay? Now, this online class is not the only Python class we have this semester, okay? There's a face-to-face class at Bandura that has another 250. There's a fourth-year master's class that has another 250, okay? So from a single university, there's 500 students at least in this one semester taking this class, okay? So you might want to, if you're doing this from the point of view of getting a job as a Python programmer, just as a Python programmer, I should say, okay? There's other specializations that you go into, and I should say that, you know, you need to look at the bigger picture, not just as a Python programmer, but if I just jump on to seek.com, Python jobs, it seems like there's quite, but you'll see a lot of them have other things other than just Python in them. But it's very well worth your while looking at the jobs and seeing where your particular discipline fits into it, because it is a numbers game to some extent, right? So if there's 500 students at La Trobe doing Python, and there's 40 universities in Australia doing a bit of math, that's a lot of people, right? Applying for 1,000 jobs, okay? What I'm getting at is that you need to really buckle down. You know, these jobs pay good money, but it's a numbers game. If you're in the top 1%, you will have an opportunity to be competing for these things. You'll be able to travel all over the world and work anywhere in the world. Quite a few people that I have taught in the past have gone on to work for, you know, Industrial Light and Magic, Google, Amazon, those sorts of things. So it is possible, right? But it is a numbers game, and you're up against it, all right? So there's a lot of people that are doing this course, and this is just one semester, right? You look at 3 semesters a year now, it's a really big numbers game. So what I suggest is, for those of you who are really new to it, is just see how you go, and if it's not for you, you can withdraw up until the census date, which is generally 3 or 4 weeks into it, okay? If you're finding it is not working for you, please don't continue to do something. It's a lot of money. It was no doubt a pretty painful journey just to enroll in this and get yourself here. But if it's really not for you, please do not waste your time continuing it. Just because you're someone who's committed to something doesn't mean that you're necessarily going to be able to do it and put yourself in a position where you're going to be able to compete with literally tens of thousands of other people for jobs in this space, okay? So I'm just giving you the reality, yeah? You look at these things and they all seem fairly financially rewarding, but it is really competitive, okay? So see how you go, but if it is not gelling with you at all, please choose a different path, okay? All right. Let me just see how we're going. Okay. All right, so let's go back to here. So part of this is to paint the broad reality of it for you. But I hope that by the end of today, you think that you can think that it might actually be not that difficult. Okay, the point is there are lots of programmers in the world. Lots of people can do it. There are people who have done brain studies to see what sorts of people are good at programming. And it turns out that actually lots of different people are quite good at it. People with musical backgrounds often become programmers. People who are good at languages. People who are good at math. Incidentally, I will stress that you do not have to be a mathematical marvel to do this course by any means. There is some very straightforward math, but it's really about the level of year 9, okay? Year 9 or 10. So if you've got some fundamental founding in math, you'll be able to get through this quite comfortably, okay? It's not a math heavy course. This is about how to program. It's not the math behind programming. There are some formulas and equations in it because programs are often used to do that sort of thing, but you don't actually have to know math. You don't have to solve equations. You don't have to write anything like that down. Anyway, let's progress with the slides. Okay. So a little bit about me. My name's Richard, as you probably are aware. You may have been expecting Josh to be taking this class. Josh is the subject coordinator for this subject, and I'm what's called the instance facilitator. Josh and I swap around these roles. Sometimes I teach online, sometimes I teach face-to-face, sometimes I teach both of them at once. This semester I'm just teaching the online one. And Josh is teaching the face-to-face, and we generally swap and mix and match. So we've got a bit of a teaching team happening, but I just wanted to give you a bit of a background so you could get a sense of what my journey was. I've done a few things. I worked at a pub one time, stocking bottles. I did work as a firefighter at another point in my career. That's the vehicle down on the right. It's a vehicle called a slip-on. I don't know if you've ever seen one of those, but it's a top-of-the-range Land Cruiser. My favourite day at work was four-wheel drive training, particularly after a rain where we'd take it down the track and just fang around in the mud. So I've had some fun over the journey, and I haven't always been someone that's programmed consistently since I was hatched, as it were. You may have seen on the webpage some of the professional Python programming I did for Melbourne University virtual environments for simulation. Had a couple of professors talking about that. Medical simulation was always a passion of mine. I had a chance to get involved in that over a few years. I worked for a web design company called Boojum in the UK, in Bristol. After I finished studying here, I went overseas and worked for a company called ClearSpeed Technology. And they were trying to make computer graphics cards at the time, so that was a fairly mathy job. And I also worked for a company called Therapeutic Guidelines. They produce independent publications to advise doctors. So there's one on antibiotics and there's 9 other publications. Anyway, the point is I've done a bunch of different things and I haven't always done programming. So I studied originally at La Trobe, went to University of Ballarat, did a PhD, and then ended up working professionally at Melbourne and bounced around a bit, and I'm back at La Trobe. Anyway, let us continue. Anyway, that gives you a bit of a sense of who I am. I like to think I'm a fairly practical person, fairly approachable. By all means, please drop me an email and just say hello if you want to. I understand that online class is very difficult. It's very hard to get to know people. By all means, if you are agreeable to somebody contacting you through the chat window, please raise your hand now so you can just chat to people directly. Nobody wants anyone to chat to them. We're all just business here. All right, Mallory, you're the only one that's going to be chatted to. Great. Oh, Julie, there you go. Julie, Mallory, you can... you don't know how to raise your hand. You can actually raise your actual hand. You don't have to do the hand raise. There you go. Mallory, maybe you need to explain how people can raise their virtual hand, since the actual hand doesn't seem to. All right, let's move on. Okay. So today, I want you to have a good sense by the end of today about how hard this is, right? How much heavy lifting you actually need to do. What the hell, let's see. Okay, so how much heavy lifting do you have to do? How does assessment work? And basically, where do we start? And how do I get you off the ground with respect to something that can really seem at first blush pretty daunting? It's not like, it might seem really difficult to start with, but the other thing too is that confusion is really quite normal when you're starting. That may sound a little bit disappointing to say, but yeah, it really is. It really can be quite confusing to begin with. So, I said give it a couple of weeks to decide, but it really shouldn't take too long for you to get a sense of what's going on. Okay. All right. Okay, so let us continue with these. Okay, so I want you to be really quite comfortable that zero programming experience is assumed for this course. Okay? There are people obviously here that have done a lot of it, that have been doing it for a long time, but where's my slide going? Can you see my slides? No, I can't see. It's too many bits and pieces. Just yeah, great. Okay. Okay, so zero programming experience is assumed. This course does not make you an intermediate or a professional programmer. Okay, it's very much pitched at an introduction, and persistence really matters. Okay, I'm going to give you some AI prompts that you guys can play around with to help you prepare for class and help you prepare for the laboratories. Okay, I'm not going to just leave you out there. Okay, so do I need to have experience to do this class? No, you don't need any. am I doomed if I have a marketing or a sales background? No, not necessarily. Not for these reasons. But yeah, zero experience is assumed. And I really want to make that point because some people find this really quite overwhelming, particularly if they haven't gone to uni for a while, or they're just coming back to it, or this just seems a really weird and confronting space. So I just want to really put that front and center for you. Okay, so let's get to the nub of this for people who might be feeling a bit daunted. So how hard is Python? Okay, so I want to talk about this in terms of language. Okay, all of us speak a language. We all have a native language. Some of you may speak more than one language. I only speak one language. I know a number of programming languages, but I only speak one. How many people here speak more than one language? Have we figured out the hand signal yet? Anyone with more than one? One, two, couple? Yeah, okay. Oh, there's a few. Okay, great. Yeah, really respect people who've learned more than one language. The thing I will say is I think learning a first language is really hard, and babies are pretty incredible that they learn languages. I think learning a second language, I would find that incredibly daunting. So the point of this discussion really is to tell you that learning a programming language is actually much easier than learning a human language. Okay, much easier. So for those of you who are thinking, oh, this is a language, I have to learn this whole lot of things. There's literally thousands of things that I need to know, thousands of words, there's grammar, there's this and that. We'll get into how much there is in a second. Okay, so how hard is Python? Okay, so let's just start talking through an analogy. So this is the most common words in English. These are the linguistic patterns. You'll note that two things. Number one, this is called Zipf's law. I'll explain the law in a second. Has any of you heard of this? No? Okay, I'll explain Zipf's law. And does anybody know what this top bar on the left is? I left out the most frequent word in the English language. Does anybody know what it might be? The? Yep. Harrison, you're all over it. It is the. Now, you'll notice that this curve kind of scooches down like this, and Zipf's law applies to lots of populations. And what that essentially says is that of occurs half as much as the, right? And occurs a third as much as the, and two, and so on and so on and so on. So given the place of the word in that list, it's relative to the most frequent occurring word. Now, this law actually turns up in lots of places. I don't even know if I can say Zipf properly, but apparently it applies to the number of people living in cities, the way lots of things are allocated. So, yeah, if you're interested, look up Zipf's law. So the 100th most common word appears 0.1% of the time. Okay. And the word the actually, does anyone know what percentage that occurs in actual written text? Anyone have a guess? No? Harrison, you guessed correctly last time. You want to go back in? 70%. If the occurred that much, that's a little bit high. But you are close. It's actually 7%. So most of the time you are actually coming across the word the. Okay, so I just wanted to start talking about language because I'm going to start talking about programming language soon, obviously. Okay, so moving right along. So out of all of the words. So those of you who have had kids in school may remember there's something called red words. and red words occur in 50% of the text. So there are 100 words in English that occur in 50% of the text, which is obviously the plus the other 99, right? So what I'm getting at is, in order to actually get a grip on a language, you can, if you know the fundamental pieces, you're actually a large percentage of the way there. You can get going. You can start to form sentences and put pieces together. Okay. So incidentally, for those of you who want to know how many words there are in each of these pieces, so there's 900 words in 25% of the text. Then there's 4,000 words in the blue. And then the remaining 3% down the bottom, the grey, there's 120,000 words. Okay, so and obviously there's technical words and so forth. So as you can see, it kind of becomes more specialised. But once you've got the first set under control, things become much easier. Okay, let's now get into the programming world. Okay, here is a little chunk of code. Okay, if x is greater than or equal to 10. Okay, Jonathan, are you with me? Give me some audio.
I'm here.
This is your first test.
Oh gosh.
So in language, we talk about words being the fundamental unit. What's the fundamental unit in programming languages? And how many of them are here?
I've already failed.
Anyone else know? Okay. So these are called tokens. Okay, so the fundamental unit in a programming language is called a token. So we have an if. If is a keyword, it's a token. X is a variable. I'm going to ask you another question in a second. Jonathan, I don't mean to pick on you today.
That's all right, go ahead.
Because this is kind of really fundamental minutiae that professionals, you get so used to coding, you just lose this kind of stuff. It's really, really fun. So greater than equal, it's a token by itself. Okay, 10, it's obviously a number, and the colon obviously means something, right? But we've expressed a line of Python. Okay, so here's my question for you, Jonathan. Is this a program or is it code?
Oh, I'd say I'm guessing here. It doesn't look like a program because it's just a statement. But I could
Okay,
be wrong on the
a single line. Okay.
semantics.
Yes, that's one good point. I'll give you a point for that one. Okay, but if it was in a much larger thing, would it be a program or would it be code?
I'm gonna lean still
I'm really
to
picking on you today, mate.
well, you've given me the answer, but I still feel like I want to lean the other way.
Like what's the distinction? What's the distinction between program and code is what I'm really thinking.
Okay, I would say a program is an actual bunch of code working together to produce something where this feels to me like a line of code because it's only doing a if statement and we're not giving an
Yep.
output or anything.
Yep. Yeah. Okay. They're very good. I'll give you points for all of that. But the particular distinction I want to make is around this individual thing called X. Okay. Now, most of the time when programmers write programs, they don't use X. They may use X when they're starting to write it, but generally they don't use X. And I won't pick on Jonathan anymore. But the reason why they don't use X is because it doesn't actually mean anything relative to what the program is doing most of the time. Okay? Sometimes in specialized fields like physics, X might mean distance or something like that. But it's only when it refers to something that's actually in the world that I'd call it a line of a program as opposed to a line of code. Okay? You see the distinction? So most of the time what I'm going to be doing with you in class is writing code. We're going to be writing very short snippets of things that allow you to get a sense of what the steering wheel is and how we drive the vehicle, right? We won't be writing programs because, as Jonathan said, they're very large things which contain thousands of lines of code. I have a friend that there's two guys, they have 500,000 lines of code that the two of them maintain, right? And they refer to something in the world. And the reason we don't refer to things as X when we've got 500,000 lines of code is because what the hell does that mean? Okay? When you write a program, you need to be able to update it, you need to be able to maintain it, and you need to be able to understand what the hell it's talking about when you look at it a day later and you've done other things, all right? If you use X, you won't understand it, okay? But when I'm explaining what an if statement is, it makes sense for me to use code because I'm just talking about an individual piece. Does that make sense? Sorry for picking on you, Jonathan.
No, I love it. You can keep asking me questions, Richard.
All good. Okay. Anyway, so the points to make is this. We've got these things called tokens. The thing which tells you where a token starts and ends are actually spaces in the text. So there's a space between the if and the X and a space between this and that. Okay? So spaces tell you where the word starts and ends in written language, and it also does the same thing in a program, except the individual pieces are called tokens. Okay. Moving right along. So now we're going to come back and think about how Zipf's laws applies to tokens in general. Okay, so we saw this if statement, and we've got all these different sorts of tokens, right? We've got squiggly brackets, we've got dots, we've got and or not. We've got a whole lot of things that are built in, right? So you'll notice the red, the orange, the purple, and the blue are all built in. The green is user-defined. Okay, so if you go back up one, the X and the 10 were defined by the users. All of these other bits and pieces, you know, there's a colon as an operator, there's an if as a keyword, you know, they're all parts of the built-in machinery. But 40% of the time, you're defining your own bits and pieces. Okay? And these are the things that we're going to be dealing with this semester. So this gives you roughly the ratio of all the commands we're going to be covering and the way that they're actually distributed in terms of the programs that you write. Now, this was actually, I generated this graph by looking at the Python standard library. There's over 1 million tokens. So this library was put together by professional programmers, and it looked at the distribution of the way the language works. Okay. So we're not going to spend too much time there other than to say, this is how Zipf's law applies, right? So operators, you've got 6 tokens that are used 85% of the time. Remember how I said in English you've got 100 words that are used 50% of the time? Well, you've got 6 operators, 6 commands, classes, and functions that are all used over 50% of the time. Okay? The point that I'm getting at is you don't need to learn 1 million words to know how to program. So a tiny fraction of items dominates usage is the point that I'm getting at. Okay, so doing some math here. Forget the math, look at the bottom line. In total, you basically need to know 43 things, okay, which will cover most of the cases. That's what I'm getting at. 43. Now, that might seem like a lot, but compared to English, where there's 100 to get to 50%, this gets you most of the way, okay? The items themselves are on the right. These are just some examples of the bits and pieces that we'll be using, okay? So the point that I want to make is, hopefully, and you take this on board, that this is a lot less daunting than learning a foreign language, all right? It is a little bit daunting, obviously. It's new. It's, this weird computer programming sort of thing. But honestly, it's actually much easier than a language. Okay, so scooching along. So if you look at the actual figures, if you actually wanted to really learn English, you're learning 170,000 versus 43 in Python. Okay, so I think it's honestly not that scary. It's still a little bit scary, but not too scary. Okay, so hopefully that gives you a bit of a sense about how hard Python is by looking at it through the lens of language. My point is that it is still hard, but it's not that hard. I hope that encourages you somewhat for those who are feeling a bit daunted by it. Okay, so how hard is this course is our next question. Okay, so this course is about some things and it's not about other things. By the end level of this course, you will still be a beginner in Python. Okay, you're not going to be an intermediate or an expert. You will know what 20 to 30% of what a professional programmer knows. Okay, which is actually pretty good. If you're doing a 3-year degree, you'd kind of expect at the end of a course to be pretty proficient. Like, this is a foundational course. It sets you up for everything else. You need more than one semester to be good at Python. And, it's like anything else. The more you practice, the better you get. Okay, I'll talk about how you can practice in Python. There are plenty of online places where you can actually go and practice Python code. And I've developed a bunch of AI things that you can also use to help you develop your own skills. Okay, so it's not data science. We're only touching one language. It's not web development. Okay, so you won't be able to do any of those things, but you will start to think like a programmer. Language, you have to learn a ton of words, and then you have to think about how you're using the language. Programming is more emphasized in thinking like a programmer. How do you take a program requirement? How do you think about it? What is it missing? How do we actually translate that into something that's gonna work for a client within a certain level of performance? So they're the kinds of questions that shift you out of language into more of an engineering mind space. That there is a performance requirement. Some tools are better than others. Some things work faster than others. We'll cover that a little bit as we go. Okay. Ultimately, everything that you're learning in Python is telling a microprocessor what to do, something that fits in your hand. You're saying, add something to this, move some data around, make a decision around this, right? So you're just going bang, bang, bang. This is what you do. This is the decision you need to make. You're writing something that's just telling a little chip of silicon what to do. Now, having said that, Python is very fussy, okay? It's fussier than your English teacher. that little chunk of code that I showed you before, you know, there's all kinds of ways that you will type something in wrong, okay? When I'm doing the actual practice sessions with you guys, I just want you to have a try. I'll be giving you little things that I want you to write through the chat window here, and I want you to copy code back into the chat window. And sometimes it'll be wrong, and I will play with it and talk about things, and we'll go on a journey, and we'll learn about things together, okay? But failure is the only option as a programmer, right? I've done a bunch of programming recently using AI tools, and I can tell you what, there's nothing more annoying than AI tools that create hundreds of lines of code very quickly, and they're basically wrong, right? It's really annoying. They can produce, they're so powerful and so wrong. I don't know how much experience you've had with that, Jonathan. Have you played much with vibe coding?
Yeah, I have a open claw running on my Mac Mini.
Okay.
Yeah, so I personally don't code at all now. I don't even review the code, but they're
Okay.
all like personal projects. They're not like I'm not doing it for a company and sending it to production.
Do you ever find yourself talking impolitely to the?
No, never, never. I let my agent do like personality development. I like give it a few tokens to like work its personality out, and I'd say it's a bit of a friend to me at the moment.
Yeah. Anyway, we'll be playing a bunch with AI this semester. And anyway, I'll show you all that as we go. Okay. All right. So how much effort do I reckon you guys need to put in? 2 hours a week out of class. Okay. I'm going to give you a prompt that you can run. So all you'll do is you'll copy and paste it into ChatGPT, and the prompt will work with you, and it will prepare you for the lecture and the lab for the next week. Okay? So those of you who come to class, we will do the assessment in class. I need to talk more about assessment, obviously, in a second. But those of you who want to do things outside class, you can do that as well. So I just think allocating 2 hours is a good thing to do. So put aside some time because it definitely needs time put into it. Right? If you're just thinking that you can, jump on and watch 48 hours worth of video lectures at the end of the semester, do 48 hours worth of labs, and be prepared the next day for an exam, it just doesn't happen, right? Programming language is like a language in the sense that it is a skill. You have to work with it, you have to develop it, and you have to commit the time. Okay, it's as simple as that. I'm telling you this because you need to know these sorts of things. So let me just show you a graph, incidentally. Can you see this graph? Okay, so once upon a time, I thought I would track attendance in class. This is for a face-to-face class. So people that did not, so it was really funny actually, because I had 200 students and basically 30 of them didn't come to any class. This was their mark distribution, incidentally. Okay, you don't really need to look at this. So probably the person that didn't come to any classes and got 84 was Jonathan, but don't do that. Get advanced standing and, let's not do this. But as you can see, attendance actually matters. Showing up matters. So if you actually went to all of the classes, you're more than likely to get a really high mark. Obviously, kind of makes sense, right? So I just thought I'd show you that because I think attendance actually really makes a difference. And like I said, this is for people who are beginning. I take my job very seriously. I really want you guys to be in the best position to be competitive as Python engineers or as people going on in your future careers. I really dedicate myself to trying to produce the best materials that I can for you guys to try and put you guys into. Because I actually think it's a great responsibility, right? I've got 200 people suddenly that whose future careers I'm kind of responsible for, right? I really take that on. So, you know, I put a ton of work into really trying to make things explainable. I try to be approachable, but by all means, feel free to contact me because I really want you guys to be successful. I think, you know, life is difficult enough. You know, I hate people to put effort into things and not get the results that they want. So, yeah, I take it seriously, and I hope you guys do as well. But also, I like to have a bit of fun along the way. Okay. All right. So I mean, the basic principles apply. More time helps, less time hurts, right? In terms of your performance, and consistency matters, right? More than intensity. If you're going to go to a language class, just showing up and listening to it and contributing is better than going to one and talking the whole time, right? Because obviously you don't know what you're doing. Okay, so consistency matters. Okay, it really matters. Okay. All right. So let's move on and talk about how assessment works. Okay, the typical average mark, as I've said, is 65 if you're not going to show up. So you can do this course solo, right? You can do all the research yourself, run things independently yourself, but it is a ton of work, right, to actually get a decent mark. Okay, so I need to talk about how this course is actually marked. So there's been a couple of changes to the work. I hope you've all downloaded the subject learning guide. I will fire that off in a second. But just to explain how this works. So there's 8 programming exercises and they're due every Friday. Okay? Now, you can get a 3-day extension if need be. But like I said, I'm going to do the programming exercises in class with you. So if you don't want to do them on your own, you want to do them in class, by all means, let's do them together. So the way there's 8 programming exercises, they run from week 1 to week 8. Okay. Altogether, they are worth 10%, and your bottom 3 marks are dropped. Okay. So if you wanted to look at it brutally in terms of time efficiency, if you get 100% on 5, don't do the rest, right? But obviously, you're missing the chance to practice your skills. So, you know, it doesn't bother me either way. At university, we have too much going on to worry what individual students are doing with their marks. Okay. So there is a programming assignment. Okay, after you've done the 8 coding exercises over the first 8 weeks, there is a programming assignment. And 20% of that assignment is going to be an oral test. Okay, so what that means is that the tutor for the subject, whose name is Zach, he will be sitting down with you and asking you questions about your code. Okay, to see what your level of understanding is. Okay, incidentally, the 3-day extension applies to all your assignments. Okay, at university, you should just be you've probably seen you can jump in on all of your subjects and get a 3-day extension. So that lets you do a bit of load balancing at the end if things get a bit crunchy in terms of time. but there is a 20% mark given to your ability to defend your code. So those of you who wish to use AI to write your assignments, which you're not supposed to do, you are allowed to do it a little bit. And those of you who have had a look at that kind of stuff, like you're allowed to have a discussion with the AI about how to plan it, but actually getting it to write code, copying and pasting code in, that's not done. Okay? Those of you who do that will get a very rude shock when the oral assessment comes, because you will not be able to explain how your code works. Okay? So, you know, that's up to you. And as I've already said, and Jonathan, I'm putting words in his mouth, may have mentioned, the AI isn't always entirely reliable in terms of what it gives you. If you know what you're doing, you see what it gives you and you iterate, and you spend your time just iterating. You get hundreds of iterations because the stupid thing just doesn't do it right the first time, right? It gets kind of in the ballpark, but you can just spend so much time telling it what it needs to change. Anyway.
I like to think of it, Richard, as like, this is my goal over here and I'm over here, but the first time I try, I end up over here. And even with programming or just talking to the AI, you're constantly moving it to where you want to be. And you can keep working on code and making it better and better and better and cleaner, and you can keep getting closer and closer to where you want to be.
Yeah, it's it's so powerful, but it's diabolically annoying at times, is what I'll say. Okay, so there will be an AI acknowledgement that you have to do this semester. So for the coding exercises for week 3 onwards, you'll need to complete an acknowledgement to do the exercise. The AI level allowed for the assignment is planning, so you can use the AI to help brainstorm ideas, but the work submitted must be your own, okay? You know, basic idea is if you copy and pasting code, or you're looking at something and typing it in, it's not actually lodging up here, right? That's the basic thing. When you come to an exam, you won't have the AI, and we're kind of interested in what's happened up here. So, yeah, it is definitely worth actually putting in the effort and doing it. And by putting in the effort, by and large, you know, you're sitting down, you're relaxing behind a computer, you've got the air conditioning on, you're drinking coffee. Where is the effort? The effort is with the frustration, right? Because you don't get it right. You get syntax errors, you get all kinds of errors. You've got to keep fixing them, patching them, getting the Python right. It's more the frustration that you're dealing with that is where the effort is. It's not actually, you know, you're just pressing keys. It's not like digging holes. I can tell you that. Okay. All right. So a key message that I would have for you, though, is that if you can do the labs and the coding exercises without looking at anything, you'll be in reasonable good shape for the exam. Okay? All right. So that's where we're up to. Okay, so I'm gasping for coffee. So I'm going to go and have one. I'm going to pause the recording for a while. When we come back, I'm going to quickly whiz through the LMS to give you an overview of that. I'm going to talk a little bit about the labs, and we're actually going to do the lab. So just in terms of the session, my lecture goes from 9 to 10 on the Monday, except for next week. Or maybe there's a couple of ones. Anyone know why next week it's on the Tuesday? It's a public holiday. Unfortunately, I'm not allowed to do it on a Monday, so I've had to make it Tuesday. I think there may be some other holidays coming up, but do put it into your calendar, because if you turn up on Monday, there'll be a very small group of people who then become increasingly disappointed that I'm not here. Okay. All right. So I'm going to run through the coding exercise with you, give you a bit of sense around that. I'm going to talk about how we think about learning programming. I'm going to talk about the tools. And then we're going to actually jump in and do the lab. So we'll get our hands dirty a little bit. We'll write our first program. We will, get something to happen. What I'm hoping to do is obviously get Google Colab going. Has anyone downloaded Visual Studio Code and going to play with that? Yeah? Oh, great. I've seen a couple of nods. Good job. There's some things in the lab that I didn't think really went far enough. I wanted to show you how to deploy a package locally and also deploy it to the web. So you'll just get, I sometimes do a few more bits and pieces than what's actually in the lab. We'll see if we get to that. Okay, coffee time. I'll see you in 5 minutes. And I'll answer questions during the break. And we're back. Okay, so what does learning look like in this course? Before we get to that, you guys have hopefully all got a bit of a sense around what the LMS looks like. I did switch over very quickly. About this subject, it's got what we're looking at on every single week, so you guys can do a little pre-reading on that if you want to. The subject learning guide has all of these details in it. It has lots of other information that's well worth reading once, just so you've got across it. On the right, you'll see there's a calendar. So if I go to February, March. So you'll see that on the Fridays, it's got, this is when the coding exercise is due. And then at a certain point, the assignment comes out. Okay, so hopefully you'll actually, integrate that calendar into your other calendar so you know when things need to be done. Okay, so assessments for this subject, as I said very quickly, there's 8 coding exercises due every Friday. You can get an extension if needed. There's a 40% programming assignment. That programming assignment will be done in Google Colab. Okay, we will open Google Colab today. We'll be very expert in Google Colab by the time we finish this course. It's reasonably straightforward. Have any of you used it before? No? Okay, it's a reasonably straightforward environment. We will play a little bit with VS Code today, but you do not need to use VS Code for the rest of this semester. The only reason I'm going to be showing you that is because it allows you to deploy things locally to your machine and also elsewhere. Okay, so there are all the details. And you'll be informed as to when your actual exam time comes out. Okay, so having had a very quick look at the coding exercise for this week, I think we should look at Visual Studio Code. Now, so when I say we'll have a look at Visual Studio Code, that's actually in the lab for this week. So the lab session, maybe we'll look at Google Colab first. So lab 1 online in Google Colab. So let me just copy this link into your chat window so you can come to the same place as me. Okay, so you can jump in. So then you can click Lab 1 Introduction to Notebooks. Okay, so this is what Google Colab looks like. The first thing that you always need to do when you jump into the lab or the assignment or anything else is copy to Drive. Okay, so that makes your own copy of the assessment. If you change what is in here, then it won't save, okay? Because this is my copy. You need to make your own, then you can edit, right? So within the notebook, there are text cells and there are code cells. Okay, so this is an example of a code cell. Okay, now I have, you may see I have a bookmark set up to open Google Colab. And I use it quite a bit. So it just creates a new Colab page. Let me copy my bookmark in here so you guys can create your own version of it. Okay, so it creates a new cell. As you can see, I've done hundreds of programs. That's why I'm up to Untitled 376. But this is what Google Colab looks like when you're starting a raw file. The one we started before already had stuff in it, but this is what it looks like when you start. Okay, so there's a couple of things to know about this. Okay, so if you jump into it and you type in Python -- version and you hit the run button, it will run your code. So once you've written some code, you can click the button and it'll run. Okay, that didn't work. Okay, when things don't work, you're going to get these nasty little errors. Now, those of you who are paying attention may have noticed that we got a name error when we were doing the coding exercise. And now we've got a name error again. Name error is something that you see quite a lot. Okay, so I'm going to go back to the basic thing that you type in. So print hello world. Okay. Now, that's a line of code. If I want things to be commented out, I use a hash key, right? So this is a comment. Okay. Now, second thing to note. Control, Enter, runs the program. Okay, so if I want to run the program, this hello world thing, I hit that and it does that. Or I can do Control Enter and it will do the same thing. Okay. So I hope you guys are getting into Colab and you're able to type this in and you're able to run these little bits and pieces. Okay, so a couple of other comments that I should make. So Control / makes something a comment. Okay, so if I can turn it on and off. Right? So we've got these hotkeys. We've got Control Enter to run a program. We've got Control / to make something happen. Okay. So I've got a question from Nicholas about, do we have a link to this or did we just open a blank Colab? So I just opened a blank Colab to type this in. Okay, when I went from the actual module into Lab 1 online, I got into this Lab 1. So now you know you can kind of click on a cell and you can either run it by using the play button or by using Control Enter. This also explains that you can set indentation. Now, there's something important that I need to tell you about indentation. Python is very fussy, and it's very fussy about indentation. So you'll notice this little program up here. See how the print was 4 spaces from the end, okay? Down here, we've set the indentation to spaces, okay? Because Python, as I said before, spaces come between tokens, but indentation spacing is actually in spaces, okay? So what on earth do I mean by this? So in Google Colab, I could go print hello, and then I can go tab, 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 right? And it looks like it's tabs, but it's actually spaces. The reason I'm telling you this is, and you'll forget it, but I'll tell you again later, in the exam, you'll be writing some code on the LMS without Google Colab, without the AI. It's just like a text editor. And you'll be so used to tabs that you'll think that you can use tabs in the environment, but you can't. Spaces is actually what the environment uses. Okay? So on the exam, you use spaces. Tabs are just a convenience. You can set it up so, as it says in here, you're setting a tab to mean 4 spaces. But if you're in the LMS on the exam and you're hitting tab, it's jumping around in the menus, okay? That's the point I'm making. Okay, so has anybody got any questions? Is there anybody who has not got into Google Colab? There's other things I could show you in Google Colab, but I think that's probably enough for now. Now, see how all of that's red? If I hover over it, it says unexpected indentation. Okay, it's really fussy about indentation. Okay, there's a ton of things I could talk to you about Google Colab, but I think we want to actually continue with the lab and do the superhero program. Okay, so back to the lab. Let's get Python set up on your computer. Now, the computer that I'm talking to you today actually doesn't have Python set up on it. So I will do this for the first time as well with you. I've got it set up on other computers. Okay, so we want Visual Studio Code. So I hope you guys have got your hands on it. Otherwise, here's a live demo of how you set it up. Visual Studio Code. Maybe VS Code. Okay. So jumped in on here. Download for Windows. Okay. So I'll run that. Okay, I accept the agreement. Just click install, install, install. Okay, does anyone have any questions they want to ask me while this is all happening? Emily just said, is it Python 3.14 we need? I don't care particularly about the version. I just download the latest or update the data. So it doesn't really bother me. Okay, where is my VS Code gone? Okay, launch Visual Studio Code. Okay, so this is a different programming environment from Google Colab. Now, professionally, Google Colab is used to develop prototypes. It's a fast prototyping tool, but it does not create something that you can give to customers, okay? Because they want things packaged. They either want it to run in a browser or in an app or, you know, as a standalone on their machine. Okay, where are we up to? Where is VS Code? VS Code. Okay. All right. So here's VS Code. It's got a bunch of stuff that we'll just ignore for now. Okay, so file, we want to go new file. And if we go back to where we were, we want to call it superhero name.py. Okay, so I open that, I copy and paste that into there. We just create the file again. So superhero name.py. Okay, so now it's asking for a directory. So I'll put it in there. I will call it, maybe it's not going to work like this, but let's see. Let me just create a directory for it. Because you need to know where things are. Okay, so my drive. Okay, so new folder, superhero. Okay. Now I've got that. Save it in there. Okay. Right, so now I've got a Python file. I'm going to copy what I had off the internet into there. And then see how that little round dot is there? If I hit Control S, that saves it. Then I need to open a terminal. Okay. Okay, so now I've got a terminal open. Okay, so here's my Zoom screen. Okay, so does anyone know how to run this out of the terminal? Okay, so see this little button over here, you know, in the top right corner? Says run Python file. Okay. So please enter your name. Bob, please enter the number of your birth month. Your superhero name is Brilliant Muffin. Alrighty. So obviously this code is working. It's not doing anything particularly funky, but it is working. Okay. So now we want to actually get something to happen from the terminal. So if we want to find out what Python version we're using, I've got 3.11.2. Somebody was asking before if 3.6 was okay. You might want to update that. So this is where the AI becomes our friend. So how to update our Python version in VS Code. Okay, this isn't really that helpful. Can you guys all type that in and see what you're getting out of there? Because you'll get something different. So see how I just asked you for how to update our Python version in VS Code. So I've got Windows. I'm just showing you how you can get a very different okay. I want to add it from within VS Code. Okay, just gives you a lot of stuff. Are you guys having a look at it to see the sorts of stuff that you're getting? Okay, so first things first. Let's get this program to actually run it within the terminal. So rather than hitting that button, how do we run it within the terminal? Well, the first thing we need to do is to actually get to our directory. So, which is not doing very much. So I have a chat with ChatGPT. Why isn't it working? How are you guys going? Have you got the Python to run inside there? Anyone? Thumbs up? Not yet, or are you just not? You're just not playing with VS Code. Oh, a couple of people got it up. Okay, so you'll see in the chat window, hopefully you guys are all looking at that as well. Marcus said you can hit Control-Shift-P inside of VS Code and you can select a version of Python if you need to. So there's a few ways to do it. I just wanted to show you what ChatGPT was giving me because there's different ways to do things. Okay. Now I need to just pause this for a while. I'm going to show you some things with VS Code next Tuesday, but I need to just cover a couple of theory bits to finish off today. So the first piece that I want to cover off is what is an algorithm, which is a long way into this. Okay, an algorithm. So an algorithm is a recipe for telling a microprocessor what to do, okay? Some of you will do a lot of cooking and you'll know that the steps is very important. Some of them, like me, will use ChatGPT to help with cooking, and sometimes it's good and sometimes it's not so good, but at least it gives you the steps. So when you write a piece of code, you are giving a microprocessor a series of steps. And programmers design something called algorithms. Nicholas is asking, is the PowerPoint available on the LMS? No, it's not. And the reason it's not is because this has been turned into a workbook. So if you look at the workbook for week 1, this will have everything you need to know in it. I'm just covering the key pieces today. Okay. So an algorithm for making a sandwich. You put 2 pieces of bread on the bench, you spread the butter, yada, yada. It's reasonably straightforward, okay? But you have to actually follow the steps. In the programming world, the microprocessor has to follow the steps. You have to give it the steps in the language that it understands. And if you give it the wrong step, it will do the wrong step. Just like before when we were looking at the coding exercises, we had hello world, we had goodbye world in there instead, right? We actually have to make sure we give it the right step. There's what we want defined in the specification. That then needs to be translated through into a piece of code, and then that needs to be tested. Okay, so then you're going to hit something called bugs. We've already seen, well, really the same bug in 2 different places, the name error bug. I'll get into details about what that is later, but it's a flaw in the software in some way, okay? You will spend a lot of your time dealing with bugs and the frustration of not being able to express what you really want to express in the program. So like I say, programming to start with is very confusing and it's very frustrating. After a while, it becomes frustrating. And then you're dealing with the AI, which brings all sorts of other levels of frustration with it. Okay. So that's really all I wanted to take from this lecture, that there are algorithms, there's a series of steps. Now, one thing to note about algorithms, if you go to a very good cafe, they will make sandwiches blindingly fast, right? Compared to my 16-year-old son who wants to browse at the fridge, right? So some ways of doing things are faster than others and are better than others. Now, we don't really cover much in terms of algorithms in this course. By that I mean actually looking at different ways of solving problems. I do talk about it a little bit towards the end where we talk about sorting, right? Imagine you have a list of numbers from smallest to largest, all scrambled up. How do you then sort them from smallest to largest? Now, there's a lot of ways of doing that, and it's been a very long and well-studied problem in computer science. We're going to talk about some of the basic ways that you can think about solving that kind of a problem. Like I said, this course is a little bit more about thinking than just learning a whole lot of words. Okay, so that's all I wanted to show you from that one. I did want to show you a little bit from this set of slides as well. Okay, so what is a flowchart? So a flowchart is a visual way of expressing an algorithm, okay? What we had before was a series of steps for making a sandwich. There wasn't anything particularly funky in that. It's just do this, do this, do this. Programs are a little bit more complicated than this in that decisions need to be made, okay? And things may need to be done multiple times. So you can kind of conceptually grasp the idea that you might draw a loop to represent things that happen multiple times. And when a decision is being made, there might be a fork in the road in some sense. Okay, so this is, okay, let's try and flowchart a house cleaning business. Okay, you take 3 employees, you ask them to clean the room, you observe 3 different processes. So if you want to actually consolidate the processes, work out a standard, this is what you might do. So what can you do? Well, you try and make things consistent. Okay, so this might be a flowchart for describing your process, perhaps for furniture cleaning. You start with the dusting of the furniture and the blinds, okay, obviously because all the dust is going to go on the floor. So if you vacuum the floor first, then you're just going to get more dust on it later. So it makes sense to do that second, right? But then if there's carpet on the floor, you do something different, right? So this is a visual way of describing a process. Okay, now once you've seen it, it seems pretty straightforward. You'll notice that there's different things in this picture. Start and stop are a red colour, and they're a different shape to some of the processes. And a decision has a different shape, and this thing down here is called a connector. Okay, and you'll notice other things, like a decision has 1 input and at least 2 outputs. And processes always have 1 input and 1 output. Start always has 1 output, stop always has 1 input, and a connector must have more than 1 input, obviously, right? So there's some ways of putting these things together. Now, in the world of requirements engineering, remember how I said you start with the requirements, you then work out some code, you then do some testing. In the world of requirements engineering, there's something called business process modeling. And there's lots of standards defining different kinds of flow charting. Funnily enough, it's used quite a lot in medical processing, but some people, it is their job just to create diagrams like this. I used to talk a little bit more about tools that are able to do this, but by and large, once you've seen it, you get a bit of a sense about what's actually going on, right? There's a microprocessor, you're telling it to do these things, it's got a start and a stop, and it's got a way of figuring out what it's going to do next, okay? I'll talk a little bit about this in future lectures, but the program knows where it's up to based on something called the instruction pointer, right? That is, it tells the program, what do I have to do next? Okay, so at the start, after the start, the instruction pointer will talk to the first thing, then it will point to the second thing. But at a decision point, the instruction pointer depends on something, okay? It could go either way. But that's the mechanism that a program uses to figure out its particular path through a program. Now, I'm only talking about a single microprocessor in this case. When you're talking about a graphics processing unit that's used for games, you've got lots of microprocessors, and this becomes a lot more complicated. But for the purposes of discussion this semester, we're just talking about 1 microprocessor. Okay, so a flowchart documents the flow. Originally, it came from the military. This is one explaining how to load a rifle grenade. I think Aidan previously looked at how this worked historically. It's a series of shapes and arrows. There's start and there's stop. There's processes. There's input and output and so forth. Now, you aren't going to be asked to draw these things, but you will need an understanding of how the flow actually works and whether that flow actually matches a particular program, because a very common exam question is, does the flow match the code and where doesn't it fit and how might you change it, okay? So understand how it works, but all I'm saying is from the point of view of the actual coding that you're doing this semester, there's no expectation that you will write flowcharts with every single piece of code that you write, okay? It's a way of expressing things at a level of detail that allows people to understand things where it's really important to get things right, like a medical space, etc. Rather than having doctors look at a piece of code, they can look at the diagrams and work out where the flow is very quickly, and figure out what's going on. Okay. Once you guys are initiated into the world of coding, you'll know the language, but other people won't. So this is one way of bridging the gap. Okay, I'm going to stop there. I'm going to hang around for a period of time and answer questions. I'm just going to stop the recording now because, people may want to ask things that they don't want recorded, so I'm going to stop it there. Don't forget, next week is on the Tuesday, and good luck with your coding exercises. And if you are watching this for the first time and I haven't met you before, best of luck for this semester. Enjoy your laboratories, and I'll see you in class.